హాయ్ ఇంజనీర్స్, ఈ లెక్చర్ లో మనం హిస్టెరిసిస్ కర్వ్ గురించి తెలుసుకోబోతాం. ఏంటి హిస్టెరిసిస్ కర్వ్, దీని వల్ల యూస్ ఏంటి మనకి అంటే, ఈ మ్యాగ్నెటిక్ మెటీరియల్స్ యొక్క నేచర్ అర్థం చేసుకోవడానికి, దాంతో పాటు అప్లికేషన్ పాయింట్ ఆఫ్ వ్యూ లో కూడా ఈ హిస్టెరిసిస్ కర్వ్ అనేది చాలా యూజ్ అవుతుంది. ఏంటి ఇంతకీ హిస్టెరిసిస్ ఏంటంటే, ద ఫెర్రో మ్యాగ్నెటిక్ మెటీరియల్ రిఫర్స్ టు ద లాగింగ్ ఆఫ్ ఏ మ్యాగ్నటైజేషన్ బిహైండ్ ద మ్యాగ్నటైజేషన్ ఫీల్డ్. సో BH or I also we can consider. So in this curve, what we will do is we will try to understand what we will do and how this curve will be formed. So whenever we are drawing the curve, initially we will be at O center. Whenever we are go on increasing a magnetizing field, then the curve automatically moves to this line. And whenever we decrease the magnetizing field, means moving in reverse direction, slowly it will decrease and moves. Even though we will bring magnetizing field to 0, some portion of the B value remains there. That is what we call retentivity. Then in order to make that retentivity 0, we will apply further magnetizing field in opposite direction and finally make that B or I value as a 0, and the magnetizing field for that purpose whatever we use, that is what we call coercivity, and we will move opposite direction. Slowly it will decreases and finally it will get saturation in opposite direction. And when we increases again, it won't go in the same direction, it will take the different path. In this path it will move from B to E and E to F and F to A. So even though we will decrease and increase in cycles, it won't take the same path. Like a loop it will form. This loop what we call hysteresis curve, and the region between these or the area of the loop will give a lot of information about the nature of material as well as the losses present inside. Now we will, whenever magnetic material is placed in external magnetic field, magnetization increases and reaches maximum point called magnetic saturation. Then if the magnetic field is reduced, once we reduce, as we told previously, it will take the path from A to B to C to D, finally negative direction. If we are decreasing, magnetization decreases but follows a different path instead of the original one. Even when H becomes 0, here, some magnetization remains in the material. This remaining value is known as retentivity or remaining from here to, right? If we go on decreasing, when negative direction if we apply H value, the magnetization becomes 0 at a point. The required reversal field is called coercivity or coercive field. From here to here, this field what we call coercive field or coercive force. Upon further reversal, replication of the magnetic field, the material once again reaches the saturation, tracing a complete loop from A, B, C, D, E, F, again A. This is a complete loop. So the closed path traced by magnetization is called hysteresis loop, showing the lag of magnetization behind the applied magnetic field. And this concept can be explained based on a orientation of the domains as well. So at a saturation, domains are oriented in a one direction completely, and in a opposite direction the domain orientation will be completely opposite, but in the middle the domain orientation slowly changes. So in this way we can explain this hysteresis curve, right? Thank you.